Good morning, students. This is Manoj Kumar, Assistant Professor from Kalpataru Institute of Technology, having a video lectures on machine learning concepts. So till now we have gone with the basic machine learning algorithms like KNN, decision tree, Bayes theorem. So now we have another two more algorithms left in our algorithm part. So that is one is neural network, the other one is support vector machines. So this is the black box methods. So there is the name given as a black box method. So what is this methods are going to do? So we shall see that transforms the input into output is unclear by an imaginary box. So till now in all the things you were predicting the output. So you were having the input X. Okay, so input was X and output was Y. You are predicting the Y. Okay, so now we transform the X into Y. Okay, so transform the X into Y by an imaginary box. So that's why we call it as black box methods. So there are two black box method. One is neural network, the other one is support vector machine. So in today's class we will get into the detail about the neural network. Okay, so come for the concept. Okay, so artificial neural network, also abbreviated as ANN. So ANN means artificial neural network. So it is one of the supervised machine learning algorithm. Means, so when you call it as a supervised machine learning algorithm, so there is X is also given, Y is also given. You have to formulate how you find Y from X. Okay, so input is also there, output are also given. You have to derive a set of steps to derive Y from X. Okay, so it is designed on conceptual models of human brain activity. So it is uses the network of artificial neurons or nodes to solve the learning problems. Okay, so it is a very important, it is somewhat dependent on our artificial method. So it will work through the set of neurons. So where is neurons are inside the nerves in our body. So network of neurons or nodes to solve the learning problem. So this is the particular example we have taken. So this is a dog. Okay, so this is a, I will give you a picture. Okay, but I won't tell you it is a dog. This is the picture. You have to predict what it is. Okay, so I will send you a picture and you have to predict what it is. You can tell one of the answer can be dog. Okay, but my answer is it is a animal. Okay, dog is a animal. So at that time you will tell the picture is a dog, but my answer is animal. Okay, so at that time your prediction is not matching to my answer. My answer is animal, but your prediction is dog. So dog is a animal. I can understand, but seeing that my answer I will be giving it as animal, and your answer you will tell it is a dog. Okay, so that means my prediction and your answer expected answer is wrong. At that time you go with a different methods. So the going with a different methods, now we call it as a artificial neural network. Okay, so that we will see the concept in detail where these artificial neural networks are used. So ANN means artificial neural networks are versatile learners that can be applied to anything like classification, numeric prediction, unsupervised pattern recognition like automation of smart disease and speech and handwriting recognition programs. Okay, so now you come for the directed network diagram. So now you see here. So first, what is the go for this particular concept? So this one is so many inputs I will give. So one output I should get. Okay. So I will send the different images of the dog. Okay. I will send the left side turned dog, right side faced dog, sleeping dog, dancing dog, so many things. But what is my expectation? Identify the animal. So identify the image. So someone will tell it is animal, someone will tell it is sleeping dog, someone will tell it is a dancing dog and all. Okay, so for now you have to go check whether, now you have to check whether it is a expected. So my output is, it is an animal, but expected outcome, predicted and expected will not be same. So if they are not same, then we go with the um, error. Okay, so if expected outcome so and predicted outcomes are same, then we tell it is a correct. Okay, so for that, now you see, so this one we are giving different messages. So x1, x2, x3, that is w1, w2, w3. So x1, x2, x3 are the inputs. We go with the input signals received by the dendrites. So can you tell what is dendrite? So dendrite means, so it is one of the neuron, inside part of the neuron, we call it as dendrite. Okay, so x variables, input variables are called as dendrite, and output signal we call it as y, that is y is a variable. Okay, so we go with the set of functions. F is the function and this one is summation. So sum of all the weights from all the inputs, so that we'll see in the next coming thing. So artificial neuron with n inputs. So see here how many inputs you are having. So W1, W2, W3. Artificial neuron with n input can be represented by formula WI/Xi. So I is equal to 1 to n WI/Xi. What is WI? Weight from each input. So W1, X1, W2, X2, W3, X3. Similarly, it goes up to Wn, Xn. So after all this, now we take it as WI/Xi. Okay, so that is the input. Next, characteristics of the neural networks. So what are the characteristics? There are three characteristics. One is activation function. Next one is network topology. Third one is training algorithm. So activation function, network topology, and training algorithm. So let us discuss each and everything in detail. So come for the activation function. So what is the activation function means? So sigma, what you give, sigma bar f. Okay, so it transforms a combined input signal into single output signal. How many inputs are there? W1, X1, W2, X2, W3, X3, up to Wn, Xn. So all the inputs are combined into single output signal to be broadcasted further. Example, threshold activation function. Now you see here, so this is the graph represented for threshold activation function. So sum of all the inputs starting from -10 to 0 are calculated to give the output that is 1. Sum of all the inputs. How many inputs you are having here? W1 X1 plus W2 X2 plus W3 X3. So everything you have to sum. Summation means, sigma means summation, sum of all the inputs. Sum of all the inputs we take it as -10 to 0. So to produce an output, how many outputs you will be getting? One output. That's why you have given here, you see 0, 0, 0. The inputs will be at ground level. The output will be at 1. Okay, so that is threshold activation. Okay, so now the neuron fires when the sum of the input signal is at least 0. So next to come for the network topology. So network topology will come for layers. Okay, so how many layers are there? The number of layers. So how many layers are there? First input x1, x2, x3 with weights w1, w2, w3. So you will pass through so many layers to generate one output, one or more output, but basically it will be only one output. Okay, when whether information in network is allowed to travel backward. Okay, so when you are going to travel backward, that is the main thing. Okay, so input layers will be there. We'll go through various layers to generate one output, one or two output layer. So in between, if the input, so depending on the input, here you see output, you'll be having two outputs. One is expected output and the predicted output. So I expect this one to become, but if I get the say predicted and expected as same, ಸೊ ನಾವು ಏನ್ ಅನ್ಕೊಂಡಿರ್ತೀವೋ ಅದೇ ಔಟ್ಪುಟ್ ಬಂತು ಅಂದ್ರೆ there is no option of going back. So some are going back. You can see here. So some of the arrows are going back. So when they go back, when the output, expected outcome and predicted outcome, I predict this one. So I expect this one. So if predicted and expected output are different, then I back propagate. Okay, that means if the expected and predicted are same, then the neural network is working correctly. Okay, so I expect a dog, animal as the answer, but some will tell dog as answer. So I expect what? Animal. They predict as dog. Animal and dog both are different answers. So both are same, but there are different answers. At that time, you back propagate. So that is the main concept. When expected and predicted outputs are different, you go with a back propagation. So through hidden layers. Okay, so through hidden layers. So when that's why we are going with a backward. So when you go with a backward, once you get the output, you compare the expected output with the predicted output. So when both are same, no need to backtrack. So if both are different, then backtrack again and find the different one. So next third one, number of nodes within each layer of the network. Okay, number of layers. Okay, so number of layers we have already seen. Input layer, last is output layer. In middle you will be having hidden layers. Okay, so number of layers. So terminology that distinguishes artificial neurals based on the positions in the network. So input and outputs are arranged in groups known as layers. So here is the data. So input are given here on Y. What is Y? That is the output. Here there is no hidden layers. So you are getting X1, X2, X3. On weight W1, W2, W3 will generate the output that is predict. What is P? Prediction. So, so what is the input nodes? A set of neurons which receives the signal from the input data. These are the input nodes. X1, X2, X3 are the input nodes which receives the signal from the input data. So what is output node? Signal sent, or this is output node. Why is the output node? The signal sent by the input nodes are received by the output nodes, which generates its own activation function, generates the own activation function to generate what? Final prediction, that is P. Okay, so now in that you come for the single layer. Next, multi-layer network. So number of layers. If it is single layer means only one layer. So see here, this is single layer. So data x1, x2, x3, y. So no in between, you are not having any layers. So that is a single layer. So when you give inputs, directly you will be getting output, that we call it as a single layer. Come for multi-layer, you see x1, x2, x3 is there. On y, you will be getting hidden nodes. So this is multi-layer. Single layer means here you see the layer is only one. Directly you are getting output. But here output you are getting through how many layers? First layer is input layer. Next you are having hidden layer. Input layers are x1, x2, x3. Hidden layers are h1 and h2. So this one is called multi-layer network. So come for the network topology. So network topology means when you are going with a forward and when you go with a feedback recurrent network. Okay, so forward you see all the directions will be moving from left to right. So no back you will be having. Okay, back you will be having in hidden layers only. So see here, first you start from data, three have gone forward. Next, from x1 to h1, x2 to h1 and h2, x3 to h1 and h2. So all are moving in forward direction only. Is anything is coming in reverse from h1 to x2 or h1 in x1? No, that type of travel is called as a feed forward networks. Understood. Now you come for the feedback, that is recurrent network. Now you see all the data are moving, but you are having a delay in H1. So you can be on loop, or you can go with H1 to X1 and H1 to X2 also, or even H2 to X2 and H2 to X3 also. Recurrent means backward. So feedback feed forward network and feed backward network. So that is called as two types of network topologies. Come for the next topology, multi-layer perceptron. So multi-layer perceptron means multi-layer feed forward network. So feed forward, okay. So that is also known as MLP. It is a de facto standard ANN topology. Perceptron means artificial neuron. So it is a feed forward. Feed forward network means all the data will move from left to right. It will not come from right to left. So moving from left to right means from input to hidden and from hidden to output. So there will be no backward propagation. That is multi-layer. Okay. Now you come for the last one, number of nodes in each layer. So neural networks can vary in complexity by number of nodes in each layer. So number of input layers, number of output nodes, and number of hidden nodes. So if it is a single layer, no concept of hidden nodes. So only input nodes and output nodes will be there. If you are having multi-layer, you will be having a concept of input nodes with hidden nodes and then the output nodes. Okay, so now you come for the next concept of artificial ANN. So artificial neural network, now we call it as deep learning. That is deep neural network. So hidden network with neural network with multiple hidden layers. We call it as deep neural network. So deep neural network means neural network with multiple hidden layers. So practice of training DNN to deep learning. So when are this used? It is used in speech and it is used in Facebook. Now you see here field of AI. Inside field of AI, you are having machine learning. Inside machine learning, you are having deep learning. So that is the deep learning concept. So this is up to the artificial neural network concepts. Okay. So working on that input output have given only the description on all the machine learning models. So programming part we shall see in the next classes. Okay, so I hope you got understood with this particular program. So that is artificial neural network. So first you go through only the concepts, then you can go in detail. Okay, so I hope you got understood. So go through the videos if you have not understood, as I will be publishing each and every video in YouTube, go through the videos and understand the concepts and become machine learning or a deep learner now. Okay, I hope you got understood. So this is up to the artificial neural network. In tomorrow's class, we will go with a support vector machine. Okay, so if any doubts, you can comment me. Thank you.